So looks like we are in. Hi everybody, welcome to today's session of UPSC by Gallant IAS. Today we'll be discussing the science and technology portion from the 2023 question paper. The 2023, the infamous one where UPSC drastically changed the kind of way the questions are being asked with the new form of the way the statements questions have been introduced. The only two kind of questions has been introduced. So on that basis, this was a slightly difficult part to attend the science and tech portion, especially because few of the options cannot be eliminated given the kind of questions we are being given, as there were no all questions were based on only two sort of questions. But still, there are a lot of questions that we could actually attempt, and we could actually make proper logical deductions based on that and arrive at the answer. So what I'm saying is, irrespective of the kind of questions or the way UPSC is been asking, whether it be only one, only two, there are rooms for us to work on and arrive at an answer and improve our chances on clearing whatever kind of prelims pattern that UPSC is throwing at us. So we can expect something similar to 2025 in 2026. 2023 is one of a kind question paper which was not repeated in 24 or 25. A diluted version of that was in 24 and 25. So I think UPSC is going to continue that pattern, meaning a diluted version, much like 24 or 25 can be expected in 26 and 27. So moving on. So let's get started. Okay, without any further ado, let's get started. And I'll be sharing some takeaways as well as some core concepts associated with these questions which are relevant in upcoming examination. Okay. In India, despite having uranium deposits, depends on coal for despite having uranium deposit depends on coal for most of its electricity production, which is true. We know that majority of our electricity comes from thermal power plants which uses coal. So that's a basic idea, and India does have uranium deposits, and more than that, India has more thorium deposits. So that's the case. That's true only. Uranium enters to an extent of at least 60% is required for the production of electricity. This is something slightly factual, and we can apply a logic as well, because if you have heard about anything regarding uranium enrichment, you know that for most civilian applications, the enrichment required for uranium is much less compared to weapons grade uranium. Actually, the weapons grade uranium needs to have 90% of enriched uranium, and I'll explain what enrichment is in a bit. So this 60% is very high for civilian application and is not necessary to produce electricity. Uranium enriched at much lesser concentrations is more than sufficient to produce electricity. See, one way to look at it is that 60% is a big number compared to the enrichment levels, and if you know that 90% is the weapons grade uranium or enrichment, we can easily mark this statement as wrong. So we can arrive at the answer as this is wrong, and we can arrive the answer as C. So 60% is much higher. This is not required for any civilian application, and we know that because most civilian or most nuclear power plants, they don't require this much of enrichment, and we have a lot of nuclear power plants, Tarapur, Kakrapar, Kodamkulam, etc., Narora, etc. And since we have so much of them, and we don't have that much of uranium, and enriching uranium to this much extent is a difficult process. With that logic, you can easily arrive at the answer. But if you don't know anything about uranium enrichment and the grades of various uranium, we can look at it. It's worth knowing. And also, India's 3-stage nuclear program is very relevant, very important. You have to learn the process and whole processes and the reactors used in that. I'll be discussing that soon. Okay. So moving on. What is uranium enrichment? Basically, natural uranium is uranium-238. But that uranium-238 is not a fissile material, meaning that we cannot initiate a chain reaction or continue a chain reaction, sustain a chain reaction with that uranium. We need uranium isotope, uranium-235 isotope. Usually the uranium is uranium-238. We need the uranium-235, which is just observed in trace quantities in natural uranium. That's the issue. If you take 1 kg or 1 kg of uranium-238, only 0.7%, imagine that, it's less than 1% is uranium-238. So uranium-235. We need much more than that for enrichment. Much more than that for any sort of nuclear related activity, whether it be electricity production or weapons or whatever. So this needs enrichment, meaning that we have to separate the U-35 U-235 from the U-238. This process is called centrifugation. It's passed through a centrifuge, and this heavier U-35, the heavier 238 settles down, and we will be trapping and collecting U-35 within these centrifuges. This is exactly what Iran was doing through their centrifuges, and various attacks has been conducted, cybersecurity attacks has been conducted in uranium centrifuge facilities in Iran, especially in Natanz. So that was in news. So it is very important. The major process by which this isotope is separated from the 238 is via centrifugation. So that's the basic idea, and we need to know few grades. This is exactly the question demand, and anyways the question has been asked, so we don't have to let it go, and we need to be thorough with that. Natural uranium 235 is only 0.7%, and majority, like 99.3%, will be uranium 238, which is of very little use in nuclear projects. So some very special reactors can actually use this natural uranium for that process, but it's not really very possible. Low enriched uranium. This is the basic and the most commonly used grade of uranium, and that is being used for electricity production. So this has got only 3 to 5%. See, that is it. The question says 60%. You can look at it, that the question says 60% is required. No, it's just 3 to 5% is required for what? Nuclear power production. That's it. Just 3 to 5%. Very small enrichment is required for power production. That's exactly why Iran has been in the spotlight, because Iran says that it is using uranium or enriching uranium for peaceful purposes or its industrial applications, but it doesn't require this much of facility, this much of centrifuges for enriching uranium to 3 to 5%. Iran most definitely is using for developing their own weapons, nuclear weapons. That's obvious thing, but the main reason is that the enrichment for normal electricity production is much less, only this much. And Indian pressurized heavy water reactors, this is a type of reactor. There are 2-3 types of reactors. In India, we use pressurized heavy water reactor, then fast breeder reactors and breeder reactors. These are the 3 kinds of reactors that we use. I'll explain about them a bit later when we explain the India's 3-stage nuclear program. So 3 to 5 is low enriched, medium enriched 5 to 20. Anything above low enriched needs international monitoring, meaning that International Atomic Energy Agency (IAEA) will be having a monitoring mechanism for anything beyond the low enriched status. LEU, anything above LEU will be needing international monitoring. And highly enriched, of course, proliferation concern is there. More than 20% has got a proliferation concern, because that is not normally required for civilian application. So if a country is doing that, there is a good chance that they are not doing it for civilian purposes, and most likely they are enriching it for defensive purposes, or their proliferation. There is a risk of proliferation happening. Proper weapons grade uranium will be having 90% or more of uranium 235. Now you can imagine the scale and how this whole thing works. Having more than 90% of enriched uranium makes for a weapons grade uranium, and that's the nuclear warhead, proper nuclear warhead, and they are strictly controlled. Of course, we know that once India conducted the nuclear test with this weapons grade uranium, NPT was formed and strict sanctions were imposed upon India, and still we are battling that with the nuclear supplies group, NBT, etc. So this is not at all used in civilian nuclear energy. Obviously, it's used for weapons grade uranium. So that's the basic idea. So weapons grade is more than 90%, and normal will be 3 to 5%. Just have that idea, and that's it. This is one of the very key factors that you need to be knowing when it comes to nuclear programs in general, because UPSC haven't asked a question about this India's 3-stage nuclear program yet. So there is a good chance that anything from this part could be asked. Whether UPSC could be asking about what are pressurized heavy water reactors. UPSC will be giving pressurized heavy water reactors and what are the major components of them, things like that, or how they work. So basically, pressurized heavy water reactor, meaning that they are a primitive form of nuclear program. They are not the most advanced one, in which they uses thorium and depleted plutonium for that matter, and heavy water is hydrogen enriched water, which acts as a attenuator or regulator. So we are controlling the nuclear process by the use of heavy water, and this process all happens inside a pressurized heavy water reactor. So that's the basic idea. There are 3 stages for India's nuclear program. We have achieved only up to 2. So the basic idea is that we use natural uranium and pass it through a pressurized heavy water reactor. This is stage 1. Passing natural uranium through a pressurized heavy water reactor, we will be getting depleted uranium as well as plutonium. Plutonium is another fissile material. Okay, plutonium we are actually making it from the natural uranium. So that's the key idea. We are not actually using or extracting plutonium directly from mines or anything. We are actually passing the natural uranium and getting plutonium as an output from this pressurized heavy water reactor, and this plutonium is passed into a fast breeder reactor. A fast breeder reactor, from the name itself, suggests that it produces more output than what is given as input, as in more output of plutonium as compared to what is given as input. This is the thing. So breeder reactors are used for producing electricity as a byproduct as well as enriching of particular input that is being given. It is not like we are providing 1 kg of plutonium and getting 5 kg. We are providing 1 kg of plutonium as well as thorium. See, otherwise it violates the basic laws of mass, laws of physics. So we are supplying plutonium from this natural pressurized heavy water reactor into a fast breeder reactor, and then thorium is also supplied, which we has got in abundant quantity. And as this process, we get electricity, of course, and we get more plutonium. See, plutonium is a very fissile material and is useful for other stages. That's the basic idea, because plutonium can easily be converted to uranium-233. That's the basic idea. And as an output also, we get 2 outputs. Basically, we get plutonium, more plutonium, as well as a portion of uranium-233. See, this uranium-233 is actually a fissile material. We can actually feed it to fast breeder fueled reactors. So this 233 is a fissile material, and along with that 233 we are supplying thorium, because why? We have got abundant quantities of thorium. So in Indian context, since we have got abundant thorium, we are using it in stage 2 and stage 3. And in this stage 2, we are producing more uranium-233, which is again a fissile material, and more thorium is there. So the whole process is self-sustained, and the only input we'll be requiring will be initial natural uranium and thorium. The rest of plutonium and uranium-233 will be produced during the process. In situ, it will be produced. So that's the basic idea, and we are supplying thorium at stage 2 and stage 3. Okay, and this is how we are making use of the thorium reserves in our country to produce electricity. See, this is the India 3-stage nuclear program, and it is envisioned by the master of India's atomic energy, Homi J. Baba himself. So his idea was, the whole idea was based on his roadmap on how India's nuclear program should be going. So this is the basic idea. Remember this, it's very important. Remember what is pressurized heavy water reactor, then what is PU fueled fast breeders, and what are fueled breeders. So remember that difference between breeder reactor and pressurized heavy water reactor is worth knowing. So that's the basic idea. Remember this picture. This has been in news for multiple times. So look at that. Moving on. In the making of how many of the above hydrofluorocarbons used? This is slightly challenging because we need to be knowing about everything. That's the basic idea. So how can we know? Like what all things we could be, what all logic we could be using? What are hydrofluorocarbons? First thing we need to be knowing. We have heard about them. That hydrofluorocarbons, chlorofluorocarbons, they are mostly associated with what? Global warming. But you need to be very careful. Hydrofluorocarbons and chlorofluorocarbons are slightly different. In hydrofluorocarbons, there are no chlorine atoms present, whereas in CFCs, chlorine is present. But they are both fluorocarbons. They are both used in refrigerants. And since it is used in refrigeration process, it is a good aerosol that is there. Then they are good foam agents. And there is a good reason why we are using hydrofluorocarbons and CFCs as refrigerants, because they are good fire retardants also, because they don't catch fire. And that's the these features, like being an aerosol, being foam agents, and being fire retardants, are the qualities that makes hydrofluorocarbons a good refrigerant in the first place. But only later we found out that chlorofluorocarbons can cause ozone layer depletion because of their free chlorine atom. Remember, free chlorine is the major culprit of ozone depletion, not hydrofluorocarbon, CFCs. Anything with chlorine is a free radical and it can destroy this ozone layer. So chlorine is detrimental to the ozone, but hydrofluorocarbons are not really detrimental to the ozone. But the issue with that is they are a GHG, greenhouse gas. They are a greenhouse gas, so of course they are major culprit of global warming. That's the major reason. And in this context, there is no sufficient ground for us to think that they can be used as lubricants. But in general, going forward, you might think that, okay, given such a compound is given, there is a good chance that all could be right. Like there might be a scenario where they could be used as lubricants. That logic, I wouldn't say is wrong. You can take that. But the issue is that in this question, UPSC has very specifically given lubricants is not there and only these three are there. But I am not discouraging you from taking a logic where, okay, things like that could be used. Having that logic really helps even if you don't have the knowledge, and even if you mark this question wrong based on that logic, because that logic will reward you in other questions, and the mistakes you commit from taking that particular positive approach will be much lesser compared to the gains you are going to get. So have that idea. This is very factual that they are not used as lubricants, but they are used as these three because their basic refrigerants have all these qualities. Okay, so only three. And like I said, hydrofluorocarbons are not ozone depleting, but chlorofluorocarbons are because of the free chlorine atom, and they are a greenhouse gas emission. Hence, Montreal Protocol is associated with ozone depletion. In Kigali Amendment to Montreal Protocol, HFCs are also added. Initially, hydrofluorocarbons or HFCs are not part of Montreal Protocol, but with the Kigali Amendment of Montreal Protocol, HFCs are also added to the Montreal Protocol. And the reason why such a GHG has been added to this Montreal Protocol is because CFC has been strongly phased out under Montreal Protocol, and HFCs are a good substitute for that. So in a way, Montreal Protocol promoted HFCs, only to know at later point that they are harmful in other ways. So to correct their own mistakes, they have to make an amendment to the Montreal Protocol to include hydrofluorocarbons, not because they are ozone depleting, but because they are global warming and a greenhouse gas is a greenhouse gas. That's it. So I hope you got the idea. Remember about this chlorofluorocarbons and HFCs. The one with chlorine is ozone depleting, one without chlorines are not ozone depleting. That really helps going forward in many examinations or many questions. That logic really helps. Moving on, carbon fibers. You all might have heard about carbon fibers, especially used in automotives. The main thing, automotives as well as in aircraft. Yeah, that's the basic idea. They're mostly used in automobiles and aircraft. The main advantage is that they are extremely light. They can be shaped into complex structures, and they are very, very durable. They are much, much stronger, almost 10 times or 5 to 10 times stronger than steel, and less than 1/5 of its weight. So that's the basic idea about these carbon fibers. This is used in high-end automobiles, race cars, as well as aircraft, where weight does matter as well as strength matters more. So instead of relying on heavy materials for durable construction, we can use carbon fibers. And carbon fibers are basically, I'll tell you the process of how carbon fibers are made. There will be a thin strand of carbon, and this will be like our sewing, normal fibers are like yarn that we use to make our clothes. It's just like that, but they are viewed in such a pattern that they form a shape, and this shape is heated in an autoclave, which is an oven, and then a resin is being applied to that, which hardens the structure. And this resin and carbon combination as a woven combination gives it that strength. And since the whole thing is very much lighter because the materials used are less dense, it is very much light. So carbon fibers once used can be recycled, just like the threads that we used in our clothes. So it can be recycled. So that's the basic idea. They are not easily recycled once they are hardened, because once they are hardened with the resin, just shredding them into smaller bits and then recycling them can affect their strength, because the structures are broken. The carbon structures are broken. But there is a way where the resin can be dissolved and the carbon fibers can be extracted, which is much more efficient way of recycling, because the strength of the carbon fibers are retained. Just a fact to be noticed, that's it. So both the statements are right. So we'll be arriving at answer C. So that's the basic idea. Carbon fiber, carbon nanotube, these are UPSC's favorite area. UPSC have, I think since 2015 I have seen multiple questions about carbon fibers and carbon nanotubes. So it's worth looking into. Then, how many of the above actions is the function of accelerometer? Have you ever heard about an accelerometer? That's the question number 1. You might not have heard about an accelerometer, but you are using one every day. If you don't know, and I think most of you might know also, every time you switch from portrait to landscape mode, your phone changes its orientation from portrait to landscape. How does the phone know that the orientation has been changed? Because the phone has an accelerometer sensor along with a gyroscope sensor also. They are both used for identifying the orientation. So accelerometer is capable of identifying the tilt of anything that is being attached. It is mostly used in mobile phones. That every day we use mobile phones and they have got accelerometer. So there are applications that use this accelerometer in phones, so that we can use the phones as a scale, as a level gauge, where we can identify the proper levels. So that's the basic functioning of an accelerometer. And having that knowledge, we can see the detection of car crash collisions, which deployment of aircraft almost instantly. Obviously, something changing its orientation in a car crash, there will be changes in its orientation. So obviously, this could be identified. True. Detection of accidental free fall of laptop towards the ground, which results in immediate turning of hard drive. Again, possible. You might have heard, if you're a tech geek, you might have observed that back few years ago, there were pop-up cameras in mobile phones, where the screens will be completely flat without any notches or anything. They will be having a pop-up camera, but the moment the phone feels that it is falling down, the camera, if it's open, it retracts inside, and that's basically because of the accelerometer inside it. So that's basic idea. You don't need to know anything about that, I'm just saying. So all you need to know is that something that can detect tilt, that's accelerometer. Detect tilt through the movement or the acceleration, that's basic idea. It can detect all of these things. Detect the tilt of smartphone, which results in rotation. Yeah, exactly, this is the one thing I've been telling you about. So basic idea. The reason why UPSC have asked about this is because UPSC needs to know, do you have any idea about the device you are using every day? The general observation that you are expected to have, that's the basic idea. Nobody is going to teach you what is accelerometer, what is gyroscope, or anything, and nobody can expect what UPSC will be going to ask next. They will be going to ask about AI, ChatGPTs, like generative pre-trained transformers, that are GPTs, or they could be asking about display technologies, because we are looking at displays every day. So the difference between LED, LCD display, which has also been asked. Such things come from the general awareness, the day-to-day use. We use these sort of gadgets, technology. So UPSC expects us to have some level of knowledge. You don't have to have a high level of technical knowledge, but you need to be knowing that there is something called accelerometer. That is what facilitates the device that we are using to identify the orientation of the screen. So that's the basic idea. So look for things like this. One important sensor in this context is like the proximity sensor. One that we, when our phone is being put close to our ears during a call, the screen shuts off, and that's because of the proximity sensor, which uses ultrasound sensors for that matter. So proximity sensor is another sensor used in phones. Accelerometer is one. Then another one is called gyroscope. So gyroscope is slightly different from accelerometer, but their functions overlap a lot, because gyroscope measures rotation and angular movement. So they can measure the rotation and angular movement. So such a rotation or measurement of rotation and angular movement can help us identify most of the things that accelerometer is doing, like the fall or the orientation, things like that. So gyroscope can actually do most of the functions that accelerometers does. So that's also possible, but in most phones we have both of these. And having this gyroscope is what helps us view images in 3D. When we tilt our phone, the image will be moving likewise. That's because of the gyroscope sensor input giving to the display. So that's basic idea: gyroscope, accelerometer, proximity sensor. I'm saying this because we are not going to discuss anything like this anywhere. So I thought it's a good time that we discuss it now. Moving on, Which of the following countries have its own satellite navigation system? I think this is something everybody will be knowing, that India has joined the Premier League of having its own satellite navigation system with NAVIC and our IRNSS constellation. So there are only 5 countries so far that has got its own satellite navigation system. And we know that it's not Australia, it's not Canada, it's not Israel, it's Japan. It's quasi-zenith satellite system, QZSS. And of course, we need to be knowing the other 5 countries which have got their own satellite navigation system, their features, and their anything important. And about India, the particular question has been asked about the IRNSS constellation. This NAVIC is the name of the positioning system, just like GPS. And the satellite system that India has deployed for facilitating this is called IRNSS, Indian Regional Navigational Satellite System. And it's a 7 satellite system, and that has got geostationary as well as geosynchronous orbits. That has got satellites in geostationary as well as geosynchronous orbit. UPSC has very clearly asked how many satellites are present in geosynchronous, how many are present in geostationary. So since the reason why UPSC has gone to that level is because it's an Indian technology, and we need to be knowing few things about that as well. So countries with satellite navigation system, of course, GPS, that's globally available, and even we are using it. I think everybody is using it. So that's one thing, and it's the oldest satellite system. It was initially used for military purposes. Later it was given for civilian use. But there is a limitation. The accuracy will be limited. In the open GPS, the accuracy will be limited to some 20 to 30 meters. So if you mark something or if your position is being located via GPS in open GPS, there will be an error of up to 30 meter, or you will be within that 30 meter radius. But the proper military grade GPS will be having an accuracy of less than 5 meters. That's like laser precision, like pinpoint precision. And of course, you know what that could be used for: guided missiles, guided ammunition, guided targets. Basically that's the reason why such precision is not open for public. It's only for military use, not civilian use. Russia uses GLONASS, of course. Russia cannot depend on USA's GPS. They need to be having their own, because they are all rivals. So that's it. European Union has got Galileo, China has got Beidou, and India has got NAVIC. This IRNSS is the satellite system that facilitates the NAVIC. NAVIC is the name, just like GPS. Okay, IRNSS is the satellite that facilitated, just like the satellites facilitating GPS. And there are, just like GPS, we have got military as well as civilian use versions. So civilian users will be having much accuracy than GPS. So even the civilian ones of NAVIC will be having much accuracy than the GPS one. But it's limited to the Indian subcontinent. Okay, India and just 1500 kilometer radius. So that's the issue with that. Very unlike GPS, which is globally available. So this is one thing, and it's of course used for military purposes and other mapping, things like that. Then Japan has also got that. That's called the QZSS, quasi-zenith satellite system, and it's used for basic navigation purposes. And the countries is because they don't want to be depending on GPS for long, because what if USA decides to stop the service altogether for countries other than USA, then the entire systems could fail. Like the maps in India could fail, everything, delivery systems, everything could fail. So in order to protect their interest or strategic autonomy or sovereignty of the nation, these countries have developed it. So India has joined that Premier League of having its own satellite navigation system with NAVIC, and some recent phones are equipped with NAVIC chip, meaning that instead of GPS or along with GPS, we can actually use NAVIC. We need that particular chip in our phone to be able to use NAVIC. That's the challenge with that. NAVIC radio, it is called. Moving on. Ballistic missiles. Yeah. Always. In science and tech, I think most of you will be knowing something about this, because this is covered in our foundation classes almost every year. Ballistic missiles are jet propelled at subsonic speeds throughout their flights, while cruise missiles are rocket powered only in the initial phase of flight. The basic idea is that cruise missiles are continuously fuel powered, okay, and they are used for precision attack, and their range is much lesser compared to ballistic. Ballistic ones are having that parabolic trajectory, and the reason why this parabolic trajectory is being used This trajectory itself is called ballistic. So why such a trajectory is used? Because it requires much less fuel. It enters the outer atmosphere, then from there it uses the gravity and it uses targeting systems to land at a target. So these ballistic missiles have got a parabolic trajectory and they are only powered during its initial flight. They are not entirely fueled during their fueled during their entire processes. So the issue with that is you cannot have last minute guidance or things like that. So their precision is slightly compromised, but they save very much on fuel, cost, etc. But they are much faster than cruise missiles because of the way they are, the way they have crossed the atmosphere, and from there they are having a kind of a free fall, and that acceleration can, cross all the sonic barriers, etc. So they are much faster than cruise missiles, but the issue is that they are not as precise because of their lack of, proper propulsion mechanism. So this statement has been reversed, and since it's reversed, it's wrong only. Agni 5 is a medium-range supersonic cruise missile, while BrahMos is a solid-fuel intercontinental ballistic missile. The thing is, cruise missiles are a superior technology. We need to be having, we need to develop jet engines that are capable of going at that speeds. We need to be developing jet engines that are lighter so that we can carry more warhead. So developing a cruise missile system is much more challenging. And that's the reason why India's the premier program or the flagship program of cruise missile is BrahMos, and it is not totally indigenous, though we have got a technology transfer and we are manufacturing it. We have got a collaboration with Russia, Brahmaputra and Moscow, that's the name of it. So BrahMos is a cruise missile. Remember that BrahMos is a cruise missile. It's technically very advanced. Cruise missiles are technically more advanced compared to ballistic missiles, not the other way around. Okay, so that's the basic idea. This is wrong. These two statements have been switched and given, and hence that is wrong. So moving on, I'll be telling you a few things about these ballistic and cruise missiles. So few examples of ballistic missiles. The one with the parabolic trajectory are Agni and Prithvi. Then ICBMs. Okay, ICBMs are just a acronym for intercontinental ballistic missiles. So Agni, Prithvi are ballistic. BrahMos and Nirbhay are the cruise missiles, and the big daddy of them all is Tomahawk from USA. So remember that. Okay, Tomahawk is a cruise missile, not a ballistic missile. That's the basic idea. So cruise missiles has got their own jet propulsion, and they are from start to finish they are propelled. They are actively propelled. But ballistic missiles are propelled only during the initial flight, and then they are on their own. That's it. And I've made a table. Just take a screenshot and learn about it. The few things to note is that ballistic missiles are much faster and they can go much longer ranges because of their lower fuel and lack of complete propulsion mechanism. But the issue is that they can be easily detected. That's the issue. They don't have much maneuvers happening. See, cruise missiles can have maneuvers, meaning that they can change their direction. Then that way they can actually bypass the air defense mechanisms of many countries. So they are much more harder to detect, even though they are much slower than ballistic missiles. The advantage of ballistic missile is that they are very fast. They're hypersonic, whereas cruise missiles can go up to supersonic speeds, and they actually cross the atmosphere. And these cruise missiles, they are just like flights and shorter style. They are like flights within the atmosphere only. But ballistic missiles crosses the atmosphere and then land on the target. And that's about it. Green hydrogen. We have been going through this green hydrogen rainbow for a while. Again, we will be discussing that. With reference to green hydrogen, consider the following statements. If you have been following the classes, you know that what is green hydrogen. Green hydrogen is basically hydrogen produced by electrolysis of water, and the electrolysis meaning use of electricity to split water atoms of water into hydrogen and oxygen. And energy to produce that particular electricity comes entirely from renewable sources, meaning it's entirely green. If we are using green energy to fuel that electricity, and then we are using that to produce hydrogen, then the entire process is green. It has got no emissions, nothing, and the byproduct of green hydrogen is also having zero emission. Such a way that this whole process is very green, and that's how this green hydrogen is being made, and that's why this hydrogen is called green hydrogen. And hydrogen, irrespective of whether it's green or gray or blue, the nature of hydrogen doesn't change. It's the way they are made. Okay, understand that. Whether it be green hydrogen, only green hydrogen can be used for directly as a fuel in internal combustion engine. Such a statement will be wrong. Don't make that mistake. Irrespective of the color of hydrogen, it doesn't matter what we are getting. At the end of the day, it's hydrogen only, and there is no difference between green hydrogen or blue hydrogen or gray hydrogen. The net hydrogen product is the same only. Only the way they are produced, that is different. So don't make that mistake. Green hydrogen, it can be used as directly as a fuel for internal combustion engine. Hydrogen can be used, so of course green hydrogen can be used. That is true. Then blended with natural gas and used as fuel for heat or power generation. Yeah, it's very much possible. Hydrogen is a good source of fuel for that. It can be used in hydrogen fuel cell. This is the biggest advantage of hydrogen fuel cell, because because if we are able to produce hydrogen cheaply and able to supply it just like petrol, we can have much efficient and least polluting vehicles there. These hydrogen fuel cell vehicles are much less polluting compared to our EVs or other forms of vehicles, because it emits absolutely nothing, zero emissions, and they have got a much lesser carbon footprint compared to EVs. But the issue is that hydrogen fuel cell technology is much expensive, and it's very difficult to source hydrogen and supply hydrogen, store hydrogen, etc. That's the limitation why we are not having hydrogen fuel cell vehicles on a large commercial scale. Companies like Toyota has been working on hydrogen fuel cell vehicles than EVs, because they are confident that this is a better alternative to full on EVs. So that's one thing, and this is right only. Moving on. Aerial metagenomics. This is where our usual skills at deciphering the keyword really pays us well. So aerial metagenomics. The name has got aerial, then it has got meta, then it has got genomics. Aerial meaning something airborne, flying, or anything that is in the air. Meta meaning something within something. Genomics meaning study of genetic makeup or genetic studies. So we have to go ahead with that. Collecting DNA samples from air in a habitat at one go. Are we clicking or are we checking all the boxes? Aerial, from air, so that is checked. Metagenomics, DNA samples are directly useful for metagenomics. So this statement kind of clicks, but it's wait, it's not. Let's not jump into conclusions just like that. Understanding the genetic makeup of avian species of a habitat. Okay, avian species, they are airborne, they are aerial, and genetic makeup, metagenomics. It's okay, but the issue is that if you are studying about avian species, why should we be naming this as aerial metagenomics? And avian species strictly includes birds and flying birds, and I think bat is also a part of that. So why should we name genetic makeup study of avian species as aerial metagenomics? It's better to name it avian metagenomics, right? Why aerial? Aerial means everything that is in the air, not just avian species. So that's another thing. Then using airborne devices, this is slightly questionable. Okay, it checks up the genetic makeup thing, but other than that, it's slightly on the tricky side, because it is very focused and not very general, and it's very specific with avian. Using airborne devices to collect blood samples from moving animals. Airborne devices, okay, aerial. Collecting blood samples from moving samples, okay, but collecting blood samples alone wouldn't mean metagenomics. Blood samples could be connected for any purposes, for study of pathological studies, just like we are collecting the blood samples from the bats during the Nipah outbreak. So that could be conducted for anything. Blood samples are not directly related to metagenomics alone. And if you are studying about genomics, you don't need to collect blood samples as such. There are other, like even hair or things like that are more than enough for collecting the genomic data or genetic information. So blood sample collecting is not at all necessary for that matter, and this process cannot be called as metagenomics. It has got aerial, but it's not metagenomics to be exact. Sending drones to inaccessible areas to collect plant and animal samples from land surfaces and water bodies. Okay, This is slightly okay because they are sending drones to collect plant and animal samples. Okay, samples are being collected, so we can say that okay, metagenomics or genomic study is there. But what is the aerial part of thing? Just sending drones doesn't mean that it is aerial. Okay, sending drones is just a way of doing it. It's not from where it is being getting. We are getting the samples from land and water bodies, and that's not definitely aerial. So that's not the case. So this is wrong. This is wrong. This is wrong because it's very specific and it has got avian thing, and this is wrong because we don't need to have blood samples for genomic studies, and if you are collecting blood samples there would be other purposes as well. And the first statement is collecting DNA samples from air in habitat at one go perfectly defines that statement, and compared to the rest of the three statements this makes perfect sense and it checks all the boxes. So this is the right answer. This is how we arrive at the answer. Anything that has got genomics, you should be looking for DNA or something of that sort. DNA or samples, things like that. And anything like blood or other samples are not that relevant. They can be used, but genomics mostly surrounds around collection of DNA samples. That's basically it. Moving on. Microsatellite DNA. Again, a question regarding DNA has been asked. I think this is slightly tricky, but the kind of logic I used, I absolutely didn't know what this microsatellite DNA was, but I was able to arrive at an answer with a, I wouldn't say a very common or a very universal logic, but one thing I've approached is that microsatellite DNA. Okay, so a DNA, it's a kind of DNA. Okay, from the name itself, I've got that it's a kind of DNA, and microsatellite DNA. And what is a satellite? Meaning that this DNA is behaving like a satellite for another DNA or something else. Satellite meaning that it's orbiting or connected to something else. Meaning that this microsatellite DNA is connected to something else. So it remains as an evidence of something else. Okay, that's the basic idea. The satellite will be having a connection with something else. So it remains as an evidence of something. That's the basic idea in biotechnology. So if one thing is connected to the other, and these things are used for identifying the changes in the other. That's how we work in in most physiology or medicine. We use that. If you find that okay, higher levels of creatinine is observed in the kidney, meaning that there is an issue with the kidney, because higher creatine signifies that lower filtration capacity or lower performance of the kidneys, thereby having an issue there. Same way, microsatellite DNA, one that surrounds another DNA, and that is being used to establish a relationship between them. So that's the basic idea. Studying the evolutionary relationship among various species of fauna. Okay, makes sense. Maybe a particular animal is having, same species of animal will be having different types of microsatellite DNA, and based on that we can identify okay, which all animals are having that particular microsatellite DNA and the ones having a different microsatellite DNA. So we can study the relationship between them. So having this satellite is basically having a relationship with something else. So this kind of makes sense. Look at the other statements. Stimulating stem cells to transform into diverse functional tissues. Stem cells and DNA. Again, something that I don't know. Maybe plausible. Okay, something I cannot decipher from this word itself. If this thing is strictly factual, I won't be able to decipher it. So no idea. Promoting clonal propagation of horticultural plants. Why are we using clonal propagation based on this microsatellite DNA? If anything that is from my knowledge, that DNA or clonal propagation, we will be using, CRISPR-Cas9, something of that sort, genetic modification. There won't be use of microsatellite DNA as such. So this seems less likely. Assessing the efficacy of the drugs by conducting series of drug trials in population. Again, if we are conducting efficacy of drugs, and how not all drugs can have an impact on DNA, how can we assess that efficacy based on this microsatellite DNA? Again, this is questionable. This seems extremely wrong, and this is also wrong. This this might be possible if it's factual, but from my logic, I'm taking a risk here actually. If I don't know the answer, and in the actual examination also I didn't know the answer, but I was taking a risk because stimulating some cells to transform into diverse functional tissues could be right about this. Maybe it could be an initiator, it could send that particular signal, things like that. But the first one, studying the evolutionary relationship among various species of fauna, is possible with that logic that the DNA and having a microsatellite DNA, and another organism will be having a different DNA and different microsatellite DNA or same microsatellite DNA. Thereby we can say that okay, having these sort of microsatellite DNA can makes that these organisms are from one place, and those with a different microsatellite DNA will be having a different place. So that kind of made sense in my mind, and that's how I arrived at the answer as A. So the basic idea is that these things are used in actually evolutionary studies, microsatellite DNA. I think anthropology students knows this answer because they are studying this, but I didn't know any of this. I was stuck between A and B, and I took the risk because this seems extremely factual, and if this thing is factually right, I would be wrong. But I felt I should be sticking with my logic, where I could be able to establish the relationship between the satellite behavior and evolution. So I thought of choosing that, and that was right only. So this is why I tell you, sometimes it can backfire. If this question has got B as the answer, then it backfires. But this is a very difficult question for everybody. But having a logic where you can reach up until to this level is in itself is a win. And from there on, move on, take a risk, and most likely you'll be clearing it. So that's the kind of mindset you need to be having. Okay. Moving on. With reference to central bank digital currencies, consider the following statement. You know what are central bank digital currencies? It's just like rupee in a digital form, and it appears as a liability in balance sheet of banks. So basic idea, and we can convert it to rupee easily in case of India. Okay, in other countries the conditions will be different, and it's not just asking about India, it's asking about CBDCs in general. It is possible to make payments in digital currency without using US dollar or SWIFT system. Yeah, this is possible. Actually, this is possible because imagine having money and you are transferring the money physically. Okay, transferring the money physically, not through any bank or SWIFT system or anything. I tell you a brief about the SWIFT system because this is something that the banks use for international transactions. Okay, I'll tell you more about that. So imagine a scenario where you are not using the bank system and you are sending the money physically. Okay, but is it possible to send that much money physically, like in billions of scale? Is it possible to send that much of money? No. But that's money when reduced into a digital currency, it becomes just like a digital asset. It doesn't have any physical presence, physical value, physical space or anything. And that particular currency can be transmitted without any US dollar or SWIFT system. Or, I mean, I'm not saying that you should be taking it physically, but having a digital path for that can be made and it can easily be transferred. That's one easy way to transfer fund. Does it make sense now? So that's the basic idea. So this is possible, and this is exactly why the nations are actually working on CBDCs, because if we angers US or the West, the first thing they will be doing is cutting us off of SWIFT system. Cutting a bank or a country from a SWIFT system is like cutting their international telephones, meaning that they won't be able to communicate with the banks outside of their country, meaning that they will be effectively localized. And you know how in a globalized world, cutting off your connection with the outside world is as detrimental as just killing you. So SWIFT is the first line of defense used by West for right as well as wrong reasons to impose sanctions on countries, especially countries like Russia, North Korea and Iran. So countries are using CBDCs as a tool to bypass this thing. So that's the basic idea. Then as digital currency can be distributed with a condition programmed into it, such a time frame for spending it. This could be right. Just like currency, government can by notification issue that okay, up until next month, for the rupee 500 note cannot be used after 1 month of time. Such a condition can be done in a physical world, then such a condition can be done in a digital world much easier. So it's much more easier to do that, very unlike the physical world. So this is true. This is actually true. And this is one reason why we can use it to, welfare measures, where we can actually reduce the lapsing of fund or misappropriation of fund, things like that. So this is a good way to curb corruption and ensure transparency in public welfare programs. So using CBDCs. I think in the coming years, we'll be, just like using bank accounts for transfer, government will most likely be switching to CBDCs for transfer of pensions or salaries and welfare measures, etc. So we can see that coming soon. And learn few things about SWIFT. SWIFT is a payment in a way banks across countries can communicate. SWIFT doesn't send money. It sends a message that this particular amount is been transferred to this bank. So it effectively doesn't move the money. The movement of money takes place through their core banking solutions. But having the SWIFT is through, it's like a channel or a communication channel within which the information is being passed. The communication or the actual transfer happens through the Nostro accounts of countries. So that's happening like that. So, but if your communication is entirely based on, imagine that if the entire communication is based off WhatsApp, okay, if a country is saying that we are sending this much money to you and you are sending this much money to us, the whole accounts and everything is kept via WhatsApp. Imagine in a hypothetical scenario, and SWIFT is exactly doing that. SWIFT is not moving the money or anything. The money movement happens through the bank only. But what if SWIFT system completely kicks you out, WhatsApp gets you banned, then your entire transaction, intercommunication gets collapsed. And this is why SWIFT is being widely used or at times misused or to threaten countries when they are saying that they are trying to move away from the dollar or gold standard measurements, etc. So that's the basic idea about SWIFT. SWIFT is headquartered in Belgium. That's one thing. Then sanctioning of SWIFT means disconnecting it from the global banking message network, making international payments extremely difficult. So in order to bypass SWIFT, countries like Iran, Russia has resorted to other measures, like they're developing their own messaging mechanism and dealing in local currencies, things like that are being done. Moving on. Green hydrogen. This is the second question about green hydrogen that is being asked in this particular paper. So see, there are very much recurrent patterns, and these questions are actually generally easy. Questions about green hydrogen are generally easy. Green hydrogen is expected to play a significant role in decarbonizing how many of the above industries? Hydrogen is a clean and a good source of fuel, and all of them requires fuel to operate, fuel for electricity or whatever purposes. So decarbonizing them using hydrogen is possible in all of them. There is no particular reason to eliminate any of them. So basically it all three. Simple. That's the logic we need. That's all. And I'll tell you a few things about hydrogen rainbow. I think it's worth knowing. Grey hydrogen, which is the most commonly used one, is formed by steam methane reformation of natural gas, meaning that natural gas is passed through steam and hydrogen and carbon dioxide are produced. The keyword is steam methane reformation of natural gas. So that's how green hydrogen is produced. But the issue is that you can observe that CO2 is produced. There are high CO2 emissions. So that's the common thing, the common practice, and the reason why we are pushing towards green hydrogen is to eliminate this CO2 emission. And another workaround for that CO2 emission is that the same way steam methane reformation is being produced, and the produced CO2 is captured through an extra step called carbon capture mechanism machinery is employed. So they can reduce the carbon capture, but it cannot completely eliminate it. That's the issue with this particular blue hydrogen. Blue hydrogen is better than grey hydrogen, but blue hydrogen requires more infrastructure to capture carbon, store them. So that's a difficult process. So all of them makes this hydrogen process, blue hydrogen, more expensive than grey hydrogen. So you can imagine that grey hydrogen is the cheapest form of hydrogen production and most emitting. Green hydrogen, it has got absolutely no emissions. But the only thing is that if the electricity used for it is coming from thermal power plants, then there is no point. It is using a byproduct of an emissions industry. Then there is no point in resorting to green hydrogen. So in order to address that, renewable energy, if you are using renewable energy for electrolysis of water to produce hydrogen, that is called proper green hydrogen. There are no emissions, and the electricity that is being used is coming from the renewable sources only. So no emissions at the source also. So that's there. And remember, the processes are different. Here, grey and blue uses steam methane reformation, whereas green hydrogen uses electrolysis. Here, electricity is used. Here, steam is used. So that's the difference. And it is the cleanest form. Okay, remember that. And There are two other forms of hydrogen, like very high emission forms. I think these are not really as relevant, but it's worth knowing. Gray hydrogen is the most common one that we are currently using because of though they are high emissions, these brown and black are like highest form of emissions. From the name itself, you can feel that like anything brown or black will be having highest emissions. So it's gasification of brown coal. Yeah, gasifying brown coal, of course, very high emissions. Then black hydrogen, black coal, very high emissions. That's there. Pink or purple hydrogen. Here electrolysis, similar to green hydrogen, electrolysis is done, and the energy source is nuclear power. So carbon impact is low. That is there, but it has got other risk because the power is coming from a nuclear power source, and nuclear technology, nuclear power plants are not that carbon efficient compared to normal thermal power plant. They are, but they are not completely carbon neutral or completely green. Also, they have they run the risk of nuclear meltdown as well. So that's not a very viable solution for that. Then turquoise hydrogen, methane pyrolysis. This is worth knowing. It is low and it's not a very very popular technology. It's just worth knowing that turquoise hydrogen is made from methane pyrolysis. Okay, that's it. So I think we have got an idea about the basic fundamentals about India's missile system, as in the nuclear technology, 3-stage nuclear program, missile, and this hydrogen, as well as accelerometer, sensors like that. So look for these basic things, that everyday things that you use in your phone, like the camera sensors or the displays, especially displays. They are the ones that matters the most. Display technologies. UPSC has got a sweet spot of asking questions about that. So that's about it. So I hope your preparations are going well, and I wish you a very happy Christmas tomorrow. So that's it. See you soon.